This is 4.6b, graphing rational functions. So you have your essential question once again. How do you graph rational functions? Notice it's the same, but you'll notice there are a few new things we're going to talk about today. So those are the things you want to talk about. Not the exact same summary as last time, but talk about the new things we learned. Okay, so we've already talked about, we have asymptotes. There is the vertical asymptote and the horizontal asymptote. We have two of them in this graph. Okay, so let's start off with a very simple one straight from last time. So we look, this is a right 4 shift. So we have our key point, 2, 3, 4. And graph our asymptotes. Then, well, we look at the questions here. State the equations of vertical asymptote. So x equals 4. So going through the x value of 4. Horizontal, y equals 0. I didn't shift it at all. State the domain and range. We'll go back to that because I want to get to the y-intercept first. Okay, so we need to find the y-intercept. So remember that means set x equals 0. So y equals 1 over 0 minus 4, which is 1 over negative 4. So 0, comma, negative 1/4. So I'm going to graph that one. Negative 1/4, about right there. And that's it. There's no x-intercept. So with that, I'm going to graph. I can see based on where my my y-intercept is, my graph is going to look something like this. And then this. This is the same thing we did. Bottom left quadrant of the asymptotes, top right quadrant of the asymptotes. Okay, now we can answer the questions like domain and range. So my domain, see, left to right. So I'm skipping the x value of 4. So it's negative infinity to 4, u4 to infinity. My range, y values, how far down to how far up. I'm skipping 0, so negative infinity to 0, u0 to positive infinity. Okay, and now where is it less than 0? So remember, that is below the x-axis. So here's my x-axis, happens to be my asymptote as well. Don't assume it always is. Find the actual x-axis and look below. It's only this one section, so it's from negative infinity to positive 4, because we always talk about x values, domain values. And there we have it. Done. Example 2. Sketch the graph. Okay, nothing different again. We have a left 3, up 2 shift. All right, so let me graph that. Left 3, up 2. 1, 2, 3, 1, 2. Draw my asymptotes. Okay, there we have it. State the equations. The vertical, x equals negative 3. The horizontal, y equals 2. Domain and range we'll get to, but we want to find the intercepts first. So this is x equals 0 for y-intercept, so I go to that. So I get y equals 1 over 0 plus 3 plus 2. Okay, so it's 1/3 plus 2. A lot of people get stuck. You don't even have to make common denominators here. This is 2 and 1/3. That is the answer. The common denominators, when you're subtracting, are helpful, and then we can divide. But even with that, you don't need it. You're taking away part of it, basically, but you can think about it. But for addition, you really don't need it. 2 1/3. So it's 2 1/3. So let's go 2 and then a little bit more, and there we have it. That's my y-intercept graphed. Okay, x-intercept. So this is setting y equal to 0. So this one takes a little bit more work. So 0 equals 1 over x plus 3 plus 2. Subtract 2 from both sides. And this is where it has a little more work, because we need to multiply by the denominator, which is x plus 3 on both sides. And remember, since it's a fraction on the right, I'm going to put it over 1. That's what we've been doing. It's never changing. Distribute there, so it's negative 2x minus 6. Make sure you distribute the negative 2 to both. This side is just equal to 1. So negative 2, add 6. Negative 2 equals 7. So x equals negative 7 over 2. which is negative 3.5. 2 goes into 7 3 times with 1 left over. So it's negative 3.5, comma 0. That is my x-intercept. So we'll put that one, negative 3.5 on the x-axis. And so you can kind of see my intercepts just told me where my graph goes. Some of you are thinking, well, it always goes in the same spot. But today we'll find that it doesn't, which is interesting. And that is with this next problem. Example 3, we have the two differences. So we have an a value on top that's not a 1. If you haven't noticed, we've always had a 1 on the top. Now we'll look at what happens with that. And then an a value on top that is negative. And we'll see what happens with that. So it wants us to sketch the asymptotes, graph the function, identify domain, range, and the intercepts. Okay, so we'll start with the shift. This is a left 1, down 4. Nothing ever changes about the shift. Left 1, down 4. Put a little plus sign right there, and then draw in your asymptotes real quick. Make sure they go through that spot. There we have it. Asymptotes done. Next, we need our intercepts. So we need our x and y intercepts. So start with the y-intercept. So set x equal to 0, 2 over 0 plus 1 minus 4, which is 2 divided by 1 plus 4. Notice it's 2, oops, sorry, not plus 4, minus 4. 2 minus 4, so y equals negative 2. 0, negative 2. That is my y-intercept, which is interesting. Because we haven't had a whole number yet. So they can be a whole number. Don't assume it's always a fraction. Most of the time it is a fraction though. X-intercept, now we set y equal to 0. So add 4 to both sides. Multiply both sides by x plus 1, the denominator. Hopefully you're starting to get used to that by now. Distribute on the left, so I get 4x plus 4 equals, right side simplifies, so it's just 2, subtract 4, divide by 4, and I get negative 1/2. So my x-intercept is negative 1/2, comma 0. Right there. Okay. With that, we're going to graph. Everything looks pretty similar. The only difference is, which it's hard to tell in just a 2, but what that graph does, what that positive value that's greater than 1 is, it pushes it away from the asymptotes right in the middle a little bit more. So it's further away. As it gets bigger and bigger, it might look like crazy looking thing way the heck out here as that number gets bigger. So notice this one, it's not going quite as close. And we never cross asymptotes. So there we go. Finally, we have domain and range. So domain and range are the same no matter what. X values, I'm skipping negative 1. So negative infinity to negative 1, u negative 1 to infinity. My range, the y values, so down to up, I'm skipping negative 4. So negative infinity to negative 4, u negative 4 to infinity. Basically, that value, the only thing that changes for domains and ranges is the number right here. They should match, and it should always be the intercept, or sorry, the asymptote that relates. Okay. Now we get into the most important one, a negative on the top. Start with our shift, still the same. So right 2, down 3. 1, 2, 1, 2, 3. Put a plus sign there, and then draw in our asymptotes. Most of you probably know what negatives do, and you could tell me what negatives do, but we're going to see it in action here. So we're going to find our intercepts, starting with the y-intercept. So I'm going to set x equal to 0. Okay, so simplify, and I get negative 4 over negative 2 minus 3, which is positive. Negative divided by a negative makes a positive, minus 3, which is negative 1. So 0, negative 1. Wait a second. That doesn't seem right. Every time we've graphed, it's been the bottom left and the top right. Well, think what a negative does to a graph. It flips it. So where the graph was here before flips, now it's going to be up here. We're switching the quadrants. That's what the negative does. It flips the quadrants that we're in. So instead of bottom left and top right, we're in top left and bottom right. Okay, which we'll confirm with our x-intercept to show that we definitely didn't do anything wrong. So it's -4 over x minus 2 minus 3. Add 3 to both sides. Then we multiply by our denominator. And distribute. And we get 3x minus 6, simplify, equals -4. Add 6 to both sides. I get +2, divide by 3, and I get my x-intercept of +2/3, 0. So when I graph that, notice that is also not where our normal quadrant's in the upper left. So we can see this one easily. Notice it's also pushed a little bit even further out from there because we have a higher number, a 4 on the top. So it's not a 1, so it's not as close. So 4 pushes it even further out. So you can kind of see that as we graph our intercepts, it's pushed a little bit further away. The other one, it's way the heck down here in the bottom right quadrant. Okay, and then we can look at our domain and range, but you'll notice once again they don't change. So where's our asymptote? It's 2, so it's -infinity to 2, u2 to infinity, and my range is -infinity to -3, u -3 to infinity. Okay, so when you're answering your essential question and writing your 3-sentence summary, focus more on these last 2 graphs we did. What did that number on top, the bigger number on top, do, and what did that negative do? Explain that. Okay, write your 3-sentence summary.